Aspergillus immunity and risk. So what do I mean by this? Okay, so somebody mentioned a primary immune deficiency. These things come up occasionally. There's one or two patients that we talk to have hyper IgE issues, and that comes from a primary immune deficiency. Primary immune deficiencies are caused by changes in all our genes. Paul has described really nicely that we have 25,000 genes, but we have 3 billion base pairs that make up those genes. Those genes, although those base pairs are incredibly stable, but you do get the occasional change, and some of those changes can cause mutations or changes, and that's why we're all still here. Those changes produce variability. Variability is the reason we can adapt as a population to almost anything going on in the world, apart from possibly Mr. Putin, but other than him. Primary immune deficiencies are essentially things that people have lived, their immune system is still working, but it's slightly changed, but it's only slightly changed enough that they're able to be born, they're able to live, and they will only, it's mild enough that the fetus is viable, if you like, the baby is viable, and they can carry on living, but they are important when it comes to things like infection, because those people have slightly different immune systems, and some of them are deficient. Now, there is also a category I'll cover at the end of the immune modifiers. Why this article exists: Aspergillosis is a mold that everyone breathes. Most people clear it without difficulty. It sticks to that mucus. The mucus is removed from our lungs, and we're completely fine. A small number of people develop aspergillosis because the balance between the fungus, the lungs, and the immune system is disturbed. This article is looking at the primary immune deficiencies, and they are nearly all really rare, but these things are inherited. This is genetic. These are the ones we're going to talk about are the ones that are clearly linked to aspergillosis. The modifiers can increase risks or severity, but do not cause disease on their own. So they're kind of slightly a milder version of these, but for aspergillosis, there are some important examples that you need to be aware of. There are around 500, maybe slightly in excess of 500 recognized primary immune deficiencies. Of those, only 20 to 30 are clearly linked to aspergillosis. All of the others, as far as aspergillosis is concerned, have completely normal immune systems and can resist infection, same as everybody else, even though they've got this immune deficiencies. They can be so precise. A fungus isn't going to get past those defenses, but about 20 or 30, which is about, 4 or 5%, are important in aspergillosis, or are linked to aspergillosis. Let's not say they're massively important. But almost everyone, they're not the cause of aspergillosis. Almost everyone with aspergillosis do not have one of these disorders. A few do, and sometimes it's important to look under certain circumstances, certain contexts, to check whether somebody has or hasn't, but it's pretty rare stuff. So there are 3 ways to get aspergillosis. Number 1, you have your immune system is slightly less good at killing the fungus. So in the airways model, where we saw that mucus being swept up to be swallowed into our gut and destroyed by stomach acid, that can be slightly made less efficient, and that gives the fungus slightly more opportunity to grow and potentially cause infection. So that's one way that we can be vulnerable. There is a slightly increased risk of invasive aspergillosis. That's the invasive form. Lung damage over time. So as we know, if you have an underlying cavity caused by TB or cystic fibrosis and so on, the risk of CPA or a fungal ball and aspergilloma is increased. And as with ABPA, if your immune system excessively activates, you end up with something like ABPA and lots of mucus and lots of inflammation. Do any of the primary inherited immune deficiencies have an influence? Well, they're rare, but they can be high impact. There are some defects of phagocytes, so those are the things that eat the fungal spores. You can imagine if they're not working absolutely at the top of their game, then you can let an infection in. You can still fight the infection, you can still stop the infection, but it's got in there and it's got a toehold, and that affects things like chronic granulomatous disease, which we did some work on way back before the formation of NAC, I think. Other forms of CGD, chronic granulomatous disease, some congenital neutropenias. Neutropenia almost by definition doesn't have particularly good phagocytes, and if you can't attack the fungus can attack you, and you end up with some really quite nasty aspergillosis infections of people at a very young age. We're talking about probably children here. Certainly CGD, I think the maximum age at one time was about 10. You get invasive lung disease, it spreads very slowly beyond the lungs, and you haven't got a good enough immune system to fight it off, unfortunately. There's hyper-IgE, that's another form. This affects allergy syndromes. There's a nice list of the different genes that can cause hyper-IgE. It's not just one gene, it's a range of genes. Typical patterns, if you've got this going on and it's not been diagnosed, if you have severe asthma and allergy, thick mucus recurrent infections that are unexplained by any other potential explanation. Even it was suggested if you have ABPA, which and a few people with ABPA do develop CPA, maybe it's worth checking these genes to see if they're present in that particular patient. This by no means is not a routine situation, because very few people have these things. But when the context is right, the doctor might decide that it's worth checking. Something called combined immune deficiency. So this is where your immune system is, all the parts are doing well, but they don't coordinate with each other very well. So you can get general susceptibility to all kinds of infections because your immune system isn't working completely as well as it should be. And these are the various different names for those types. Aspergillosis can behave aggressively because your body isn't protecting itself as well as it should. So sometimes if we're in a situation where that's happening, then you might be asked to check for these genes. I'm assuming when I'm saying this that there is a test for these genes. I assume there is, but I don't know 100%. Beth might be able to tell me later.